Hi everyone, this video is about SAP integration using MuleSoft Mule 4. Let's start with what is SAP. To say in simple terms, SAP is an ERP system which holds all the master data and different types of records of an organization. One use case for SAP integration with MuleSoft would be when an organization wants to sync its master data stored in SAP with an CRM like Salesforce. You can download the SAP connector from Exchange. Once downloaded from Exchange, you will be able to find it in your Mule palette and view all 9 operations supported by the connector, that is, asynchronous remote function call, confirm transaction, document listener, function listener, get function, retrieve IDOC, send IDOC, start SAP transaction, synchronous remote function call. From now on, we will discuss how to configure the SAP connector. In this page, we see the SAP Java connector libraries. These three jar files are required to import in all the SAP config. These jar files are available to be downloaded from SAP website, but it requires SAP ID. So you can take help from your project's SAP basis team to download them. These jar files can be added as local files or deployed to any binary repository like Nexus. After that, it can be added as Maven dependency in the Mule applications form file. The first two jar files, IDOC library and JCO library, are same for all operating systems. The third one, JCO native library, is different based on the different operating systems. Where SAP JCO3.dll is for Windows, libsapjco3.so is for Linux or CloudHub, libsapjco3.jnilib is for Mac OS. If you are working on Windows system and deploying on CloudHub, which is Linux system, then in your local development environment, you will use the jar ending as .dll. And when you are about to deploy to CloudHub, you will switch and point it to .so. The most common deployment error occurs when we forget to switch the jar files between deployments. Now we will talk about configurations of the SAP connector. We start with SAP authentication. SAP config follows two authentication types. In first type, we can provide a X509 certificate. Then it used when the MuleSoft is acting as a client. Here we don't give the SAP username or password. In second authentication type, we provide username and password. In both type of SAP authentication, we also require common parameters which are system number and SAP client ID. These details are also available from the SAP basis team. Once we have chosen the authentication type and configured it, next we have to understand if we are connecting to a message server host or a application server host. Message server act as a load balancer over application server. If we are connecting to application server host, we will then require to provide the host or IP, which is configured here as acp.host. If we are connecting to message server host, we will need to populate the message server host, message server port, and SAP system ID. Next topic in SAP connector configuration is reconnection strategy. If on SAP listeners relies exclusively on the JCO library, which means that the Mule reconnection mechanism has no impact on reconnection. The reconnection works in such a way that for the first time it waits for a 1 second and tries to reconnect, then it waits for 2 seconds. Likewise, it doubles the wait time till it reaches 1 hour. With this, we have completed the minimum SAP connector configuration required for our SAP integration to work. For additional fine-grained configurations, please refer to the MuleSoft documents. Next, we come to the data exchange options available in SAP. There are two types of data exchange. First one is IDOC. IDOC is a standard data format defined by SAP for the exchange of information between SAP and SAP non-SAP applications. IDOCs are typically used when information needs to be sent to or from SAP without notifying requirements, primarily used to transfer master data in and out of SAP. The second one is BAPI, which is Business Application Programming Interface. BAPI are defined interfaces that can be called either by SAP or non-SAP applications, typically in synchronous scenarios. Let's start with different IDOC operations. We have the document listener, which is placed at source and listens to or listens for IDOC. All listener connectors placed at source have the gateway host, gateway port, and program ID to be set to facilitate gateway registration. Program ID created should be unique. It can receive one or multiple IDOCs in a single request based on the batch size configured at SAP side. Next is retrieve IDOC operation, where we give the IDOC name and it retrieves it. Next is send IDOC operation. Here we can send the IDOC to SAP over RFC. It can be TRFC or QRFC. For TRFC, to enable TRFC, you can set transaction ID. To set a transaction ID, we first call the start SAP transaction connector, which returns the transaction ID in response. And once the operations are done, we commit the transaction using confirm transaction connector, which accepts the same transaction ID as input. To enable QRFC, you can mention the queue name. Here we have some sample IDOC messages. This is a sample IDOC. This is the payload that we can see after IDOC document listener connector. The first tag, the ORDERSO5, is the name of the IDOC. Inside the IDOC name segment, we can see a segment called EDI underscore DC for T. Generally, this segment is present in all IDOC and contains the metadata related to the IDOC. All other segments and fields might change based on the IDOC you are using in your project. And inside EDI dot underscore DC underscore 40, we see a field DOCNUM. This represents the IDOC number and it is used to uniquely identify the IDOC. In this request, we see single or multiple IDOCs. As discussed before, we can receive single or multiple IDOCs in a single request in document listener based on the batch size set at SAP side. Now that we have covered the IDOC operations, let's look into some BAPI function operations. First, we have the synchronous remote function call. It executes a BAPI function over srfc. When you mention the function name in this connector, the function metadata request response structure gets loaded, which makes the transformation part very easy. Next, we have asynchronous remote function call. It executes over TRFC or QRFC. As it is TRFC, so we need to provide the function name as well as the transaction ID. We will fetch the transaction ID similarly using the start SAP transaction connector, and when all operations are complete, we will confirm the transaction using the confirm transaction connector operation, giving the transaction ID as input. So we might want to store the transaction ID as a variable when we receive the start SAP transaction, receive it from the start SAP transaction connector configuration. Next, we see function listener, which listens to the BAPI function, and it is very similar to HTTP listener. Here, our request is triggered by SAP, and after your operations is complete with the request, you form the response payload to send back to SAP. This connector get function will retrieve the BAPI function if you provide the function name on demand. In this page, we see a sample RFC request. The first tag is the function name. Then we have broadly two sections, import and export. If we are listening to BAPI function, the request parameters will come in import. And if we are sending request to a synchronous RFC function, we will transform the parameters in the import section. The export section contains the response. If you are sending back a response to function listener, we will form the response payload parameters inside the export. And if we are listening to the synchronous RFC, then we will get the responses here in the export section. So this slide is basically based on my project experience. So program ID creation is required for IDOC listener and function listener, which listens to BAPI function. For each unique listener listening to a IDOC or a function, we should have a unique program ID. While deploying a IDOC listener flow, if you are getting an error that gateway registration has failed because this host is not allowed, where it will mention your IP address, then in that case you have to check if the IP is allowed at SAP side in SAP external security. If you are using VPC, then give the VPC CIDR range to SAP external security to be configured as allowed. Next one is when a SAP IDOC is sent and it is received in MuleSoft, and when you log the received IDOC, you are seeing that it is not readable or as expected, then most probably the SAP is not configured to accept Unicode communication. You can do it in SAP by setting communication type with target system in SM59 for transactional RFC destinations to accept Unicode. As we saw when we discussed about SAP connector configuration, we need to provide three SAP library jar files. All three of this library is required, so if you miss any one of them, it will result in error. If you are missing the JCO native library, you will get an error like java.lang.exception in initializer error, no SAP JCO3 in Java library path, but you may have given the Java SAP JCO3 in your Java library path, but maybe the wrong one. This error will also come when you have given a wrong library which is not compatible with the operating system. Example, using the SAP JCO3.dll in CloudHub. If you are missing the JCO library, then you will get an error as java.lang.no class definition found. If you are missing the IDOC library, you will get the no class definition found error stating IDOC metadata unavailable. Other error related to jar file is when we are using different versions, say using a 32-bit GCO on a 64-bit system. So we have to be cautious about those things when we download the jar files. Also, please remember the SAP connector supports 3.0.x version for the libraries. We covered SAP connector, which helps us to connect to SAP ECC system. But there are other SAP connectors which also helps to connect to different other SAP systems. Now, I will give a brief overview on them. MuleSoft SAP Concur connector. This works on top of the SAP Concur REST APIs. Next, SAP S/4HANA connector. This has two flavors, OData and SOAP. OData connector, which is built in top of OData APIs exposed by SAP S/4HANA Cloud and on-premise. Common use case for this connector is to perform CRUD operations on entity types of SAP S/4HANA's OData APIs. The other one is SAP S/4HANA SOAP connector, which is built on the SAP API that is exposed by the SAP S/4HANA Cloud ERP. The latest 2.1 version of this connector also supports SAP S/4HANA on-premise ERP. Last one, SAP SuccessFactors connectors, which provide full support to query, create, update, and delete entities, that is CRUD operations, using the OData API exposed by SuccessFactors. Now all these other connectors are built on top of APIs, so the configuration will be similar how we configure API based on API-based connector configurations. That's it, guys. Please like and share if you like this video. Subscribe to my channel for more such contents. Don't forget to comment down below. Happy learning!